to my Prezi on standard number 4, content and instruction. I chose to do a Prezi instead of just typing the paper on the page because there's a lot of information to be put on here, and I thought it'd be better to do a presentation. So I hope you enjoy. This standard number 4 is on content and instruction, but I really feel that it can be broken into 2 sections, both content and instruction and then mathematical skills, mathematical procedure skills in particular. So we're going to cover mathematical skills first, and keep in mind as I walk through these skills that these are ones that will be in every content area. They're what drive instruction and assessment, and so when I'm talking about the content, keep in mind that each of these skills are embedded in my instruction and assessment. Problem solving is the first skill that I want to address. We help students learn to problem solve by asking them open-ended questions. We try and leave the door open for them to solve problems on their own. We also structure I also structure my environment so that I can apply and adapt multiple ways to solve problems. I give them opportunities to solve problems in a variety of ways. You'll see that at the bottom here I say look at my problem solving lesson plan, and in that lesson plan I give the students the opportunity to solve this problem about going around Mileage Club and how they would figure that out, and they can do that in a number of different ways. They could draw it out, they could envision walking around the Mileage Club, which they do frequently. So there's a lot of different ways that they could try and solve it. Another way that we work on problem solving is through self-discovery. Typically we want to have our students discovering why something works the way it does before we just throw the equation in front of them. An equation doesn't really make any sense unless they've figured out what each of those variables mean and why that variable is representing what it is. So we always try and have them discover it first. And then the last thing that is really important is time to process. They need a time to reflect and think about their problem solving skills, and if the way they chose to solve the problem was the best route or the quickest route, or if there was another way that would have worked. One thing that I like to do in my classroom is to have students share how they problem solved, and that way they can see how their peers are problem solving and possibly choose one that would work better for them the next time around. There is an abundant amount of ways to problem solve in mathematics. In my problem solving chapter reflection, I shared about one particular problem solving method that I struggled with, honestly, and I reflected on how I would apply it to kindergarten and realized that not every problem solving strategy necessarily needs to be applied in every grade level or even in each class. I think that it's important that we think about the problem solving strategies that are available and then pick and choose which ones are appropriate, and be able to help students develop their own problem solving strategies given the subject matter that they're using. So I just want to draw your attention to the part below where it says see buttons for. Unfortunately, I was not able to link these directly to my document, so you'll have to go to the website page where you are viewing this Prezi from, and the list of all of the artifacts are below it in order by my Prezi presentation. So with that said, let's move on to the next skill, reasoning and proof. Reasoning and proof is one of those foundational skills that we build from the very beginning. I'm a kindergarten teacher, and so when I think of these skills, I'm often thinking from a lens of teaching it in kindergarten. So as I walk through reasoning and proof, you might see some of that emphasized a little bit. So building understanding through personal schema is one of those ways to build reasoning, and for a kindergartner, it's often trying to get them to understand things based on their little surroundings, and in kindergarten it's all about them and their personal space. So So typically when I am doing story problems and such, I use things that they would understand. For example, sitting at the dinner table, we do addition with people joining them for dinner and leaving for dinner and that sort of thing. That way they can understand. It makes sense to them. They have seen a dinner table. They've seen people sitting down at a dinner table. Another is explain the process. In kindergarten especially, this is very difficult because their vocabulary is small and it's time to start building on the mathematical vocabulary. So just every day I'm having kids explain, well, how did you get there and what did you do? Can you explain this to your partner? I think that it is important to have them explain their thought process out loud. It allows me as a teacher to assess whether they're making correct assumptions and doing the process correctly, or if they're making errors in their thinking, and that helps me to be able to help clarify if they are making errors. The next is ask, does it make sense, and how did you get there? This is one that I learned that especially once you get into abstract math in middle school and high school, you have to go back and ask, well, does that make any sense at all? So when I ask that question, does it make sense, not only are they evaluating whether the argument makes any sense, but they're also having to think about whether that would be a reasonable answer. In the last point, I write, take me through the steps to get to your conclusion. In my shared problem 2, you'll see that I pose a question for them to think about, and this is one that I would ask them to take me through the steps of how they get to their conclusion. I would be looking for the types of reasoning and the methods of proof that they would be using to come to the conclusion that they do. Alright, let's move on to the next skill, mathematical communications. Mathematical communication is vital to students understanding mathematics. When a student is challenged to communicate their ideas, they have to organize their thoughts, they have to analyze and evaluate whether their thoughts make sense. Communicating forces a student to be more thoughtful in their mathematics, and it really does make them process their math in another way. So listed here are some ideas of ways that I use mathematical communication within my classroom. We do a lot of songs. Again, that's probably a kindergarten thing, but they learn the concepts through singing. Also, describing, modeling, and writing vocabulary. We are constantly introducing new vocabulary, and being able to draw it and describe it and explain it to another person helps them understand the vocabulary better. The next point, explaining your reasoning and answer, is just like the last skill I addressed, in that being able to communicate your thoughts clearly to another person helps you to get your thoughts clearly across and to evaluate them and all that. The next is share it with a friend. In my stage 3 learning plan, you'll see that I build that in daily. We are constantly talking to our peers, telling them how to do something or reflecting on something, what we learned, etc. I love this last point. How would you show or tell your parent how to do this activity? This can be really interesting with little ones with small vocabularies, so I like to ask this to my students and see how they would explain it to their parents. And often I find out that they do go home and they explain it to their parents, and that's a pretty cool thing. I can learn just as much about a child's abilities in math by them telling me how to do something than me just watching them do it. So mathematical communications are very important. Alright, so now we'll move on to the next skill, mathematical connections. Mathematics, more than any other subject area, builds on prior knowledge. Each skill that they learn will be added to and added to and added to. So if they miss one, it becomes an issue. as a kindergarten teacher, it's really important to find out what their prior knowledge is coming in so that we know where the gaps are and can fill those in quickly and have a solid foundation to start with. I believe to make math memorable, as my website is called, math needs to be connected to everyday life. So you'll see in my community problem number 2 that I connect a story problem to everyday life, in Alaska that is. I use a story problem based on the Iditarod and 2 of our winning runners to see who's going to come in first given the speed that they've been going at. So that's just one example of how I tie in everyday life. And part of tying mathematics into everyday life is tying it into other subject areas as well. So often you'll see mathematics tied into my science curriculum, into my reading curriculum. I think the more we put mathematics into everyday life, the more students realize that math is all around us and it's not as intimidating and scary. The most critical math connection is being able to connect to new mathematical concepts. As I said at the beginning of this slide, math connections build on prior knowledge, and the more math concepts you have, the more they're going to intertwine and build on each other. Alright, let's move on to the next skill, mathematical representations. Mathematical representations are the visuals. They're what we and students use to model and interpret mathematical ideas. Before getting abstract, students need a chance to use concrete representations. In kindergarten, I spend a lot of time teaching students how to use mathematical representations and which ones are best to use. In upper grades, it would be more having students pick which representation would be best for whichever mathematical idea they were working with. The artifact I chose for this skill is the Community Problem 2 graph. In the last skill, I put on their Community Problem 2, so you saw the problem regarding the Iditarod, and now you get to see the graph. I'd also like you to take a look at Stage 3 Learning Plan that I added later, but you'll see that I have an entire unit plan based specifically on creating graphs. I think that this is a vital thing for students to learn, and I'm challenging kindergartners a little bit to learn how to use technology in using graphs, but this helps them early on to start learning how to make a mathematical representation of data that they're collecting. Mathematical representations go hand in hand with mathematical communication. So with mathematical representations, they're building, creating, or using a mathematical representation to then communicate their mathematical ideas. We've now covered all of the mathematical skills that I'd like to address today. Do remember that as we move on to the content and instruction, that each of these skills are embedded into the content for both instruction and assessment. The first content strand that I'd like to address is numbers and operations. Numbers and operations has some of the most foundational mathematical skills in the math content strands. In kindergarten, this strand has the most emphasis. Number sense is the most basic skill in math, yet it too becomes more and more complex as new concepts are introduced. For example, a student learns to count to 10, then they start using 5 and 10 as anchor numbers, like 5 and 2 more, or 10 and 3 more. See the numbers and operations lesson plan for an example of this. Then fractions and decimals are added to that concept and they rearrange their schema to fit that in. You'll see in the fractions quiz how number sense can be helpful in making sense of fractional parts. When students struggle, I often check these number and operation skills first because they're so foundational. And it is through representations, problem solving, reasoning and proof, communication, and connections that I teach numbers and operations. Let's move on to the next content area, algebraic concepts. Algebraic concepts are made up of patterns